Welcome to Aerospace Structures. Today we'll be covering the analysis of a small satellite subjected to launch accelerations. I have invited Mr. Uday, who is going to help us with this tutorial. And I had introduced Mr. Uday in a previous video, but he has been extremely helpful in helping us develop some tutorials in ANSYS to be able to analyze these systems. And in this example, our goal is to import an existing geometry, learn how to apply acceleration loads to a satellite, and then interpret the results. And so here, the solid model that we'll be providing, it's a small satellite that will be attached to a launch vehicle. This satellite is going to have to survive some acceleration loads. And so the analysis we'll be conducting is how we apply these acceleration loads to this body of material and then analyze the deformations and stresses that result from them. So I hope you enjoyed this tutorial. Over to Mr. Ode. Thank you so much.
Hey guys, this is your course producer Shreyas. I would like to thank Professor Vinay Goyal for this opportunity. So for this project, we will be performing finite element analysis of a CubeSat. So let us proceed. So in the toolbox towards the left hand side, navigate to static structural and double click on it. So once you have a window named A pop up in project schematic, we need to define material for the geometry. So in order to do that, double click on engineering data here. So we can see the default material is structural steel. Now we need to add aluminum alloy, and in order to do that, general materials in engineering data sources and navigate to aluminum alloy and click add. So once you have done this, go back to engineering data sources. We can see that there are two different materials now. So now we can proceed to delete the structural steel by right clicking on it and selecting delete. Now we can return to the original project schematic by clicking on project tab here. So once we do that, now we need to define the geometry of the CAD. Then double click on engineering data by double clicking on geometry and wait for ANSYS discovery to open. So once you have ANSYS discovery open, we should insert the geometry. To do that, click on the three dashes here and click on insert geometry and insert the step file or the CAD file which has been provided to you. So once your geometry has been imported, it should look similar to what is being displayed on my screen here. So now save this particular geometry and proceed to the next step. So after you save this, we can minimize this discovery window and click on model in order to mesh this geometry. So double click on model and wait for the ANSYS modeler to open up. So once you have ANSYS modeler opened up, the interface should look similar to what is being displayed on my screen here. So now towards the left side, we have outline has the project tree. In project tree, we can see a question mark right next to geometry. In order to resolve that, click on plus symbol here, and for this particular geometry, we need to define the material. To do that, click on it once, and in the details tab here, we need to assign the material. In order to do that, click on assignment and select aluminum alloy. So once you do that, we are ready to define the mesh for this geometry. So let us proceed to mesh. For this particular geometry, we need a tet mesh, and in order to do that, right click on mesh here, select insert and select method. Now in automatic method, we have details of automatic method here. Select the entire geometry by clicking on this CAD import and select apply. Now we need to change the method from automatic to tetrahedrons. So once we are done with that, we can click again on mesh, and in element size, in the details of mesh, in element size we can change it from default to 0.05 and click on generate. So once the meshing is done, the geometry should look similar to what is being displayed on my screen here. So now we can proceed to static structural and define the boundary conditions. Initially, we need to define fixed constraints on one hand. In order to do that, right click on static structural, insert and navigate to fixed support. So we'll be selecting multiple surfaces on this geometry in order to fix. So what you need to do is zoom in, hold control and select multiple surfaces. The first surface would be this, second would be this one, third is the one here, and this is the fourth surface. Remember that while selecting multiple surfaces, you need to press and hold control key, and once you have selected all these four surfaces, click on apply. So once we have defined the fixed support, we'll be applying acceleration, and in order to do that, right click on static structural, go to insert, and on the top we have the first option as acceleration. Go ahead and select that. So now in details of acceleration, we need to define it not by vector, but with respect to different components in all the different axes. So now we'll be able to define acceleration along each component, that is along x, y, and z. So let us change it from 0 to 70 meter per second in all directions. So once we have entered 70 meter per second square in all direction, we can proceed to plot the solution. So in solution, let us right click and insert strain and select equivalent von Mises. And also we'll be requiring total deformation. For that as well, right click on solution, insert, and in deformation select total. Now we have defined the requirements of the solution. Let us go ahead and solve it by clicking on solve here and wait for the solution to run. So once the solution runs, this is how the plot should look like. We will also be able to run the animation by pressing play here. So this is the end of the first project. And also, like if we want to see the equivalent elastic strain, we can do that by pressing on by clicking on equivalent elastic strain here. And now in order to verify if we have completed our project, let us go back to the original project schematic. And if we are able to see all the green tick marks here, it would basically mean that we have successfully completed our project. So this is the end of the project. Thank you guys and all the best.